All right. So today is day 2 of organic chemistry. Today we're going to talk about carbohydrates and lipids. So the reason why I put these two together is that these two are your energy storing organic molecules. A lot of people mess up inside this unit and they always like to say that proteins give you energy. That's not the function of a protein. So anytime you see anything about energy, this is where your mind needs to go. It needs to go to carbohydrates and lipids. Those are our our energy giving organic molecules. And so that's what we're going to be talking about today. So carbohydrates are our sugars and starches. They typically end in the prefix OSE, such as this sugar ends in OSE, and this is called glucose. It's a very common type of simple sugar. It's considered to be a monosaccharide, and this right here below it, this is the molecular formula of it. This is 6 carbons, 12 hydrogens, and 6 oxygens. We'll actually be talking about this specific molecule a lot this year, whether we're talking about photosynthesis and cellular respiration, we're talking about energy, and then we're getting into ecology and talking about the flow of energy and how it moves through an ecosystem. So we will be talking about this a lot. So it will be very important for you to remember this organic molecule being glucose and glucose being a carbohydrate. So, what are carbohydrates made of? Their subunit, or this is that term I told you from video 1 that we'd also see, it could be monomer. The prefix mono means one or a single. Saccharide means sugar. So, we're talking about one single sugar. Or monomer just simply means one molecule that we're looking at here, the simplest form. Now, whenever we take this monosaccharide and we can sit there and put two monosaccharides together, that will form a disaccharide. That's what right here, the di, that actually means that we're talking about double or two of them. And polysaccharides would be 3 or more. So poly means many, and then saccharides would be sugar. So let's talk about having many monosaccharides stuck together. So right here, I do give you a list of the 4 polysaccharides that we're going to talk about. It's going to be a starch. Starches are the ones found, are the carbohydrates that are found stored in plants. We're talking about like potatoes. They're very rich in starches. And so whenever a plant makes through photosynthesis makes glucose, well, it's going to store some of that glucose because that glucose is energy. It's going to store some of it. Well, like a potato, it's going to store it as a starch, or it's going to store it in that meaty area, which we eat. Now, that plant's also going to use it and is going to sit there and make cellulose. Cellulose is what's going to make up a plant cell wall component. So that's going to be for like structure, not for energy. This is also what, whenever you do eat a lot of plant-based products, like let's think of something that's really fibrous because that's what we would call it. We call it fiber, like celery or broccoli, things like that that have a lot of meaty substance to it. That would be that cellulose. Glycogen, though, is whenever you eat a carbohydrate, whenever you go and eat a potato and you eat that starch, well, we don't store it as starch. We actually make it into a new polysaccharide for our body to use, and that's called glycogen. It's typically stored in the muscles. It can also be found in the liver. And then this last one down here at the bottom, everybody wants to pronounce that CH with a ch. That's actually chitin. That's another structural component, but this would be the one that makes up our fungi cell walls. And whenever we say fungi, we're talking about like a mushroom. Okay, so that's your polysaccharides. You will need to know each one of those and where you find them out. So that's what's in parentheses there. You will need to know each one of those. Quizzes, tests, everything. Got to know it. Okay. So the function of a carbohydrate has a pretty sweet and simple function. We're talking about short-term energy storage. This is what your body wants to use. This is what your body wants to use to sit there and give you a clear head, to where you can actually think. This is what your brain runs on. And that's what this is. Now, the more simple the sugar, the more immediate access to it. That's why you can get like a sugar rush if you just eat something that are really, really sweet. But if you eat like a potato, you don't get that immediate rush, but you do get energy that will sustain you for longer. But that's that short-term energy storage. It can also make up structural components like the plant cell wall or the fungi cell walls with chitin. So some common foods would be like fruits, potatoes, pasta, rice, vegetables would be common foods that you would find carbohydrates in large quantities. Not large quantities of food, but in a higher amount of carbohydrates found in those foods. These are the types of foods that long distance runners, sprinters, athletes, anybody that's going to be doing any type of athletic event where they're going to need a lot of energy, these are the types of foods that they're going to eat before they have a big race or a big event, and that's known as carbo loading. Carbo meaning carbohydrate, so carbo loading. So this right here, I just want to give you some images of it. So right here we have a single monosaccharide. That is one single one right here. Now, if you notice, they actually all kind of look pretty similar. Now, this one over here only has 5 sides, so it's a pentose sugar, but it doesn't really matter. They all still look pretty similar, but you notice that they do look a lot different from that really odd shape with the nucleic acid from day one. So they're all going to be very geometric. Now, if we go over here to the one to the right, it has this sugar here, but then it's also connected to another one. So this is 2 monosaccharides that are stuck together. Well, that makes it a disaccharide. And down here, if you look at this long chain, we have monosaccharide, 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 and they're all stuck together. This would actually happen in a lot of different ways, and that would be our polysaccharide. And based on how they're all connected together is which one they are out of those 4 that we were talking about. So the next one is lipids. First off, we need to make sure that we know what a lipid is. Whenever we say lipid, we need to definitely be able to know that it's fats, oils, and waxes. If you can remember that a lipid is a fat, it will help you know what a lipid is made of. A lipid is made of glycerol and, what's that word? Fatty acids. That will help you identify it. A lot of people mess up with lipids and they say that their subunit is something else out of the other ones. If we can really connect that it's a fat, it makes this whole part a lot easier. And I'll show you what a glycerol and fatty acid means. I have some images of it later on. So we're going to first look at a fatty acid chain. We have 2 different types. We have a saturated and an unsaturated. You will have to know the difference between it. Saturated fatty acid chains are connected with a single bond, and that's what I have shown here. And on the next slide, I have an image to sit there and actually really bring that in. They're solid at room temperature, so we're talking about animal fat. These are the ones that are unhealthy for you. So if your mom cooks bacon, or if you cook meat or something like that, and then afterwards you have all that grease that's left in the pan, and then you pour it in a glass jar, and then you come back a little while later and you're starting to see that starting to turn solid. The solid, that's the saturated fatty acids, and they're just congealing together. Whenever they hit room temperature, they'll turn solid. While an unsaturated fatty acid, they're going to have some double bonds. That's what I have that equal sign there for, because that's what it looks like whenever we actually look at it, which you'll see in a second. And because of that double bond, that causes them to be liquid at room temperature. These are our healthy fats. So if you go look in the cabinet and you see some vegetable oil, well, it's an oil, so that means it's a lipid, and it is liquid. And because it's liquid, that's how we know that it's going to be full of unsaturated fatty acids, which are your healthy fats that you need to be eating. Also, there are other things that have a lot of them in it. And then, of course, right here at the bottom, if you see anything that has 3 fatty acid chains, which I'll show you what that is, and I have an image of this, and 1 glycerol, that would be a triglyceride. The tri meaning 3 fatty acids, and the glycerol being that 1 glycerol there. It kind of looks like a capital letter E. And I'll show you what I mean. It's at toward the end of the slides. So this is what a saturated versus an unsaturated fatty acid looks like. If you notice this saturated one, right here between all of these C's, because this would be part of that glycerol chain over here, but where the black part of this, where all of these C's are, you notice that there are only one line in between each one of them. There's no double equal sign line. And because of that, we know it's saturated. It's completely soaked with it. These would be the unhealthy ones. Whereas we come down here to unsaturated, as we move down all these carbons here, we come down here and we see this double bond. Because of that double bond, there's a break in it, and it also starts to bend. This lets us know that this right here is unsaturated, so this would be a healthy fat and liquid. So functions. Now lipids have several functions. You will need to know each one of them. Remember how I said that this is our energy storage molecule? Just like carbohydrates, carbohydrates were short term, but lipids are long term. Long term. Formation of cell membranes. We're going to be talking about cell membranes so much this year. So you're going to need to make sure that you know this term right here where it says phospholipid. Phospho means that there's a phosphorus connected to that glycerol and the fatty acid chain. And I'm going to have an image to show you what that looks like. They're also good for waterproofing. That's the reason why, like, if you take a glass of water and you pour oil inside of it, they don't mix together. But that's because oil is a lipid, and lipids are insoluble, which means they don't mix with water. And because of that, that's the reason why it doesn't mix there. And then, of course, great for insulation, keeping warm, cushioning your organs inside your body. So that's another function there is insulation. So this is what I was talking about. I was going to have a picture of to show you. So if you look at this, if you don't mind the lettering inside of it, you just look at the gray and then the yellow. It kind of looks like the capital letter E. The yellow right here, these would be the fatty acid chains. And if you notice on this one, all of these C's, they all have single bonds. So this right here would be, all of these would be saturated fatty acid chains. These would all be saturated, and this is that glycerol, which is the side here. That's that anchor. We come over here to the phospholipid. This right here, these legs coming down, these are our fatty acid chains, but you see how this one is bent? This fatty acid chain is bent, so that means that this one right here has an unsaturated fatty acid here. Here, up here, we have that glycerol, and then we have that phosphorus. Now, right here at the very side of it, you see where this says hydrophilic head? Hydrophilic means that it likes water. Hydro meaning water, philic means to fill it up with water. It loves it. But down here it says hydrophobic tails. And that's what we call these fatty acid chains on a phospholipid. We call them the lipid tails. But phobic means to be scared of or to reject. So it rejects water. These tails reject water. And we're going to get really deep into the cell membrane in a few units. So that's it for day 2. So let's just have a quick review. So the 2 organic molecules that are responsible for storing energy are carbohydrates and lipids. Another name for a lipid, we can sit there and talk about fats. That's a very just common name to throw out. And then, of course, other examples would be like oils and waxes. List 3 foods where you could find carbohydrates. I gave you a list of those. Fruits, pasta, rice, potatoes, vegetables. You could get that in. What's the main function of a carbohydrate? The main function is short-term energy storage, but it's also a structural component. What are the functions of a lipid? That's the ones that we just talked about. Biggest one, long-term energy storage. And then we have making up cell membranes. That would be the phospholipid. And then we also are going to have waterproofing and insulation. What are the 4 polysaccharides? Well, that's whenever we're talking about the starch, the cellulose, um, the chitin, and then lastly the glycogen. Make sure you know the purposes. That's what was in that parentheses there. Starches is how plants store their energy. Cellulose makes up the plant cell walls. Chitin is going to make up fungi cell walls. Common type of fungus would be a mushroom. Um, and then, of course, glycogen is how animals store energy, and we do that by storing it in our muscles and in our liver. What is the difference between a monosaccharide and a polysaccharide? Monosaccharide is the single subunit of a carbohydrate, while a polysaccharide is many monosaccharides stuck together. What is the difference between a saturated and unsaturated fatty acid chains? A saturated is going to be the unhealthy one. That's the ones where it's nothing but the straight lines connecting all the C's together. They're unhealthy and solid at room temperature, typically comes from animal fats. And the unsaturated fatty acid chains, those are the healthy ones. They're liquid at room temperature, and they have that double bond, so it'll actually cause the fatty acid chain to bend. All right, and don't forget, we still also have quizzes on these two as well. Please use that as a resource. If you have any questions, just email me. Thank you. Bye.